Hello, this is question 4 from the 2008 MAT. We've got some geometry going on by the look of it. Let P and Q be positive real numbers. Okay, let capital P denote that point. Okay, it's on the picture. Q denote, right, that's just describing the picture and saying that P and Q are positive and real. So that's the only thing that we've got new in the description there. Show that the equation of the circle which passes through P, Q and origin is that. Find the centre and the area. Okay, it's interesting that they put the equation first, saying show that, then find the centre, because usually we find the centre in order to find the equation of the circle. So I don't know, well, whatever. Let's see then. So this QP, well, it's got to be a diameter because we've got a right angle in that, what will then be a semicircle. So we've got PQ is a diameter. So that's going to give us then the centre of the circle. Therefore, centre is going to be halfway along the diameter. So halfway along P, halfway along Q. So the centre is going to be at P over 2, Q over 2. So that's covered that bit. The area is going to be, I'm actually doing all of this backwards. Therefore, the area is going to be, so its area is pi d squared over 4, isn't it? That's the area of something, and d squared, well, we've got that, is p squared plus q squared. So that is just pi times p squared plus q squared over 4. So far so good there. Then to get the equation of the circle then, I suppose we'll just, yeah, I suppose that's what we're doing. We've got r squared there, it's the area divided by pi. So let's go for the equation of the circle then. It's going to be x minus p over 2 squared plus y minus q over 2 squared plus equals p squared plus q squared all divided by 4. But we need to show that it's in that format. So let's multiply everything by 4 because that's going to get rid of all of those 2's and 4's. So multiply everything by 4. Means we'll have 2x minus p squared plus 2y minus q squared is p squared plus q squared. So 4x squared minus 4px plus p squared. And then the same for y. So 4y squared minus 4qy plus q squared, so they're going to cancel the p squareds and the q squareds. So we're left with, we can divide by 4 as well, so we're cancelling that with that, that with that, and then that, and that all cancel off, leaving x squared minus px plus y squared minus qy equals 0. Okay, so that was the first bit. Okay, I ended up doing it in reverse order, but hey ho. Second part, show that the area of the circle divided by the area of the triangle is greater than or equal to pi. Okay, right, there's a couple of ways we could probably go about doing this. There's the option of thinking, well, should we look for the limiting case? When are we going to get the smallest amount on this? Is when the area of the triangle is at its maximum. And the area of the triangle being largest is when it's going to be half a square. So the equality in this inequality is going to be when we've got half a square there. So we could do it that way, but I think that's going to be a bit of a cop-out. I'd like to try doing it the other way as well, because that would be saying that this has got a minimum value. I'm going to squeeze it up here because it's not going to be my main answer. Min value when P equals Q, as in we got half a square, which means that the area of the circle is then going to be, well, pi divided by 4 multiplied by 2p squared. So pi over 4 multiplied by 2p squared, and the area of the triangle is going to be half base times height, so that's going to be a half p squared, or half of that square. So that will cancel with that, and then we've got a half divided by a half, so that ends up being pi. So that's one option, but I want to try doing it a bit more generally and say, let's change to red so I can see what I'm doing. Area of the circle, which we know is pi times p squared plus q squared, all divided by 4, divided by the area of the triangle. So that is a half p times q, half p times q. So that is equal to pi p squared plus q squared over 2pq. And we're wanting to show on that, what we want to end up is saying that that is greater than or equal to pi. Right, so sometimes, right, okay, I can see which way this is going to go because I've done very similar questions to this in the past. But if you can't always see what's going on here, what we want to end up getting to is that this is greater than or equal to pi. That's for sure. So we certainly want that. You can start working backwards from your final result is one way of doing this. So we could say we wrote that at the bottom of the page. So we're then saying next line up. So imagine that I've got this written at the bottom of the page. Let's work backwards and see what that entails in order for that to happen. So we'd then be saying, well, to save a bit of space, we've got that p squared plus q squared has got to be greater than or equal to 2pq. And we know we can multiply by 2pq without affecting the inequality sign because they're both real positive numbers. And now we can, if we go backwards again, we've got this step. And this comes up quite often actually in proofs because this is p minus q squared. You just factorize that, p minus q squared, which has to be greater than or equal to 0 because it is something squared. So we got a way of working backwards and say, okay, well, that is what the ratio is by just plugging it into what they've given us on the left-hand side. Then let's work up the page and show that because p minus q all squared is greater than or equal to 0, then this inequality holds. So, like I say, I've seen that sort of thing many times before. You may have done as well. So keeping an eye on these ones. When you're seeing parts of a quadratic, then yeah, keep in mind that can be useful for factorizing and proving things in these show that type of questions. Right, last part then, I'll go back to blue. I might be able to squeeze it on the page. Find the angles OPQ, OQP, so these two angles here, if this ratio is equal to 2 pi. Right, so let's go back then to say, well, really, and I need to save a bit of space. So we're saying that this expression here on the left-hand side is going to be equal to 2 pi. So let's cancel the pi's and multiply by 2pq is going to give us then that we've got p squared plus q squared is equal to 4pq. That's what we necessarily need on this. So that's going to be p squared minus 4pq plus q squared. And we can see this is going to be symmetrical. It doesn't matter, p and q are interchangeable. So we're going to get a plus and minus solution for this. And it doesn't matter which one we've called p and which one we call q. We're just getting the two angles. One's going to be the plus solution and the other one's going to be the minus solution. So yeah, let's complete the square on this one then. So we're going to have, I'll deal with p. It just seems a way of going about it. So p minus 2q squared. So we'll have to take off 4q squared, add on a q squared. So we've got minus 3q squared. So that's going to be equal to 3q squared. So p is going to be equal to 2 plus or minus root 3 all times q. Now the way this is helpful, of course, is we're looking at these angles here, and we're going to have tans of angles by doing p over q or q over p, whichever way around it is. So it doesn't really matter. We've got two angles. So our two answers are going to be tan theta for these two options, theta 1 and 2, is going to be 2 plus or minus root 3. So it doesn't matter which way round. In case you're wondering why, okay, we got theta and we got phi. One of them is going to be q over p. The other one's going to be p over q. So we've got two of those options. but it doesn't make any difference in terms of the plus and minus, because if we've got a 1 over 2 minus root 3, then you can bet your life that if you then rationalize this, so 2 plus root 3, multiply top and bottom by that, we're going to get a 4 minus 3 on the bottom, so we're going to get a 1. So 1 over 2 minus root 3 is equal to 2 plus root 3. So that's the two options that we've got. So we can say that each one of these is going to be one of the solutions. We've got a 2 plus root 3 and a 2 minus root 3. So that's what you get with these symmetrical situations. So yeah, that was actually a fairly straightforward question, providing you can get this bit in red here, where you can actually spot the way of showing this. But it'd be interesting to know, I mean, I don't know, not being someone who marks this, as to whether they would consider this special case of saying, well, okay, this minimum value is occurring at total symmetry. So set that's the smallest it can be, this ratio is pi, and it must go up from there. I mean, it's not wrong in any way. So you might get full marks for taking that approach instead, but you've got two options at least for that middle section. It'd be interesting if any of you on working out the first section have actually come up with the equation of the circle before finding the centre and the area, because it just seems so natural to do, well, the centre's just immediately obvious, the area is not far behind, and then let's work out the equation afterwards. So if you have done it in a different way, then it'd be interesting to know what it was that immediately put you on to doing the equation first. You know, maybe something instantly occurred to you that didn't instantly occur to me. You know, I was immediately looking at the center. Maybe you saw something else. So yeah, if you have done that, I'll be interested to know what it was that you did. Not that I've got any issues with the solution that I've come up with. So there you go. That was a pretty swift one, that one.